good about it. LCP is, after you sort all the suffixes, what is the common, okay, my bad. So LCP array is nothing but LCP of I comma I plus 1 for all i's. So you build n minus 1, you have to call this function n minus 1 times and you will have the LCP array ready. So what is special about LCP of I? It's nothing but if this is the, okay, it is most probable that the I suffix and I plus 1 suffix will start with the same character. Why? Because they are in the sorted order. In the sorted order, the consecutive things may have a largest common prefix. So let's say like SSB and SSAB will be closer in the LCP array. So if you want to calculate the longest common prefix between, okay, what is a prefix for two suffixes? A subarray. So we can solve many problems which tries to maximize the subarray with some property. So that's one more property for LCP arrays. So LCP of some random x comma y, right? For some x some y, it is nothing but the min of the LCP array of x comma of x. The LCP of x will be LCP of x comma x plus 1, right? Okay, let us call the array as underscore LCP and the function as LCP. So LCP function of x comma y will be nothing but min of underscore LCP of x comma underscore LCP of x plus 1 till underscore LCP of y minus 1. Do you get it? What this intuitively means is I have two suffixes in this order x and y. I want to calculate what is the longest common prefix between them. So the longest common prefix between them is nothing but the minimum length for all the consecutive things from x to y. Okay, this is actually a very good property to use, so I'll take some more time to explain how that is true. So let us say with lines x is some this suffix, and let us so this overlap is actually the common prefix. So the consecutively they will differ in a minimum possible way. Like if you compare these strings, right? So these strings they have only a common matching to this assume. I'm just taking them as intervals. So the difference between these two intervals will be smaller than the difference between these two intervals. So what? After some, so let us call this x. Let us call this y. I wanted this part. Okay. So actually, this means actually the prefix. Like if we just consider them as intervals of matching, so the LCP of x comma y will be this interval. That will be the length. So this is nothing but the minimum one between the two consecutive things. So which will be somewhere here. Or the LCP can also be 0. Like from x to y, right? If x starts from A and if y starts in B, the LCP of A comma B will be 0. So will there be a 0 somewhere? So if this y was some bx and if something, and if A was some ay, and there is some az and a ba here. So for these two suffixes, right, I and I plus 1, the LCP array will be 0. So for LCP of these two, it will be the minimum for all these minimum consecutive things for all these segment, right, and there will be a 0 here. So LCP of this whole thing is because like this is the bottleneck. This is causing this whole thing to be 0. So LCP of xy will depend on all the smaller consecutive intervals. So let us do a problem. Okay, take this. The problem is given a string. Find the substring that occurs. Find the longest substring that occurs at least m times. Take some time. Then any method. There are lots of methods to solve this problem. So given a string n and m is the number of times that a substring should occur. Find the substring is which belongs in n. So we solve this for m equals 2, right? We solve for the longest repeating substring. How do you generalize it for substring that occurs at least m times? Tell any method, like it can be solved with Ashen, KMP, brute force. Just tell me, start from the least. What is the brute force method? Take every substring, there will be n square substrings, and for each substring I have to calculate how many times it occurs. So that I can do in two ways. I can do the brute force method for matching, so that will be on the n square. So brute force will be n power 4 because n square number of substrings, and I'll match each substring by the brute force n square. Or I can use KMP. KMP will still have n square substrings, but it will have only O of n matchings. Like it will take O of n for each substring. So it will be n cube. Can you think of any method with hashing? Question is, given input string, find the longest substring that occurs at least m times.
Binary search.
Oh.
Because if a substring of size s occurs, s minus
S1
1 will
should
also occur.
Yeah, okay. So you get so you can binary search on the length of the largest substring. So his thing is, if a substring of length s is occurring m times, then the substring of length s minus 1 will also occur at the same times. So that is a monotonic either. So it will be nothing but one. You have to binary search on something like this. Like 1 is all possible. So the lower level lengths are possible. At some length, it won't be possible to have at least n. So you have to find the last one where it is possible. So what is the function for each bit? Or how do you solve it? In binary search, it's the binary search part. What will be the function?
Rolling hash and push into one set.
Okay.
And map and count every
Okay.
time the hash.
That's it. So let us say that so mid will be the current binary search value, right? I have to check if f of mid is possible or not. So what will be f of mid? So let this be the n length string from 0 to n minus 1. So I have to go check all the substrings which are length mid, right? So it will be 0 to mid minus 1. 0 to mid minus 1, right?
Yeah.
And then it will have 1 to
Mid.
Similarly 2 to mid plus 2 till the end.
Mid.
So there are only O of n minus mid